Welcome to this YouTube channel, and the topic we are discussing now is factorization and expansion. Please, I want you to take rapt attention and listen to every bit of this production, and you'll be glad you did. I want you to know that this topic is very important topic, and it crosses across a lot of levels. I want to start with expansion. In expansion, we need to expand some question inside brackets. Now, this one, I have 2x plus 1 in one bracket and x plus 5 in another bracket. The method I want to use here, the first bracket, I want to split it, thus. Then the second one, which is x plus 5, I put at the back of the first one and at the back of the second one as well. Then I expand. If I expand, I have 2x multiplied by x plus 2x multiplied by 5. Then I have 1 multiplied by x and 1 multiplied by 5. Then I have this answer. What you need to do now is to collect the like terms. So having collected the like terms, you have this answer. This is another one. In this place, as usual, I split the first bracket. That is 3 minus x squared. Then I put the second one, 2x plus 5, after 3 and also after minus x squared. Then I open the bracket where I have 6x plus 15 minus 2x cubed and minus 5x squared. Note, when the value you have in front of the bracket is negative, when you are opening the bracket, note what happens, because a lot of students, they make mistakes as this is concerned. Now, what we need to do is to collect the like term. So having collected the like terms, we have this answer. But I want you to note something, that is advisable that you arrange your answer in order. In this case, x cubed comes first, then x squared, then x, then the constant. This is another question. This question, I have the first one, the negative is inside the first bracket, and also negative is inside the second bracket. That is, in the first bracket I have 3x minus 5, second bracket I have 4x minus 5. So as usual, I split the first one like this, then I put 4x minus 5 behind the first one and behind the second one, then I open my bracket. Here I collect the like terms, then I get my final answer. This is another scenario. In this scenario, I have 2x plus 5 brackets all raised to power 2. In this place, this question can be written in another way. Although when we are talking about additional mathematics, you have a way of doing this type of question. We call it, but it is under binomial expansion. So we have Pascal's triangle, and you can use the binomial expansion formula. But in this place, I'm doing in such a way that every standard, both young and old, can learn from this. I'm not using additional math method here. So this one can be 2x plus 5 in one bracket, 2x plus 5 in another bracket. It's like when you have 2 raised to power 2 is 2 times 2, 4 raised to power 2 is 4 times 4, 5 raised to power 2 is 5 times 5. So 2x plus 5 all raised to power 2 is 2x plus 5 bracket 2x plus 5. Now I do it as usual. I split the first one, then the second one I put it behind the first one and behind the second one, which is 5. Then I open my bracket. Then I collect my like times. So this is my final answer. Now this is another question. And in this question, I have 3 brackets here. In the first one, I have 3x plus 1. The second one, 2x minus 5. The third one, x squared plus 2x. This one is the first one. This one is the second one. This one is the third one. There are many ways by which you can answer this type of question. You can multiply the first one and the second one, then later multiply the answer with the third one. You can multiply the first and the third, then later multiply with the second one. You can multiply the second and the third, then later multiply by the first one. But to avoid confusion, I want to use the simplest one I can think of. That is, I will multiply the first and the second, then I will multiply my answer with the third one. So here, this is the first and this is the second. I want to multiply now. So I pick the first and the second. Then, as usual, I split the first bracket. I put that one behind. I put this 2x minus 5 behind 1. Then I open my bracket. Then I collect my like times. So this is the final answer of that one. Then I bring the third behind. Now, for me to expand this one, I can think of a better way of doing this. I can interchange. Put x squared plus 2x in the front. You can do it like that, it's okay, but for easier method, that's why I do it like this. Now I have the question, then I split the first one, then I put the second bracket behind x square and also behind 2x. Then I open the bracket, I get this one. Then I need to collect my like terms. I put the like terms together, then I simplify. So this is my final answer for this. Now factorization. Under factorization, I have this question. Factorize 6x squared plus 2fx. In this place, you can look at the first one and the second one. 6 can go in 6x squared and 6 can go in 12x. The second term, x can go in x squared and x can go in x. So I will take 6x, then the remaining thing I will put inside the bracket. Now, 6x going in 6x squared is x. 6x in 12x is 2. So the answer is 6x in bracket x plus 2. I can call factorization like the opposite of expansion. And if I expand this, what the answer I will get is 6x squared plus 12x. Another one. 3x cubed minus 48x squared. In this place, if you look at this question, what can go in 36? The highest factor that can go in 36 and 48. Then x can go in x squared can go in x cubed and x squared can go in x squared. So if you look at 36 and 48, 12 can go in both of them. So I pick 12x squared. So 12x squared divided by 36x cubed, I have 3x. 12x squared divided by minus 48x squared, I have 4. So this is the answer for that. This is another one. In this one, when you look at the first one, second, we have 26mx cubed, then minus 65m squared x squared. When you look at 26 and 65, what can go? The highest number or highest factor that can go in 26 and 65 is 13. So I put 13 aside. Then m in the first one, m squared. M can go in the first one behind 26 and m can also go in m squared. So I pick m as well. In the third one, x squared can go in x cubed. X cubed means I have x times x times x, and x squared, x times x can go in x cubed, and x squared can also go in x squared. So I pick x squared. So what I will have outside the bracket will be 13mx squared. So the remaining one will be 2x minus 5m. How do I get 2x minus 5m? When you use 26mx cubed divided by 13mx squared, you get 2x. When you have minus 65m squared m squared x squared divided by 13mx squared, you get 5m. So this is the final answer for that. Now we have something we call difference of two squared. When you have x squared minus y squared, it is x plus y in bracket x minus y. If you have a squared minus b squared, is a minus b in bracket, then a plus b in bracket. If you have p squared minus q squared, is p minus q in bracket, p plus q in bracket. So this is the basic thing or the fundamental thing you need to know about difference of two squares. Now, I want to do some examples on difference of two squares. Now, 1 minus b squared. Somebody can just think that 1 minus b is not difference of two squared because 1 is just single. But note that 1 squared is equal to 1. So 1 minus b squared is a difference of two squared. So 1 minus b squared is equal to 1 minus b bracket 1 plus b. If you try to open this bracket as we did in expansion, the final answer you get will be 1 minus b squared. Now this is another one. A raised to power 4 minus 1. Now if you look at a raised to power 4, you can split it down to a raised to power 2 bracket 2. Like this. A raised to power 2, then you have to, in indices, when you have something raised to power something, then in bracket another, you can multiply the power together. So when you multiply that 2 and that 2, you get 4. So you can split a raised to power 4 down to a square bracket square minus 1. Then if you look at this is the difference of two square. So it will give me this as answer. A square minus 1, a square plus 1. But note that this one is also a difference of two square. So I need to break it down. So a square minus 1 will give me a minus 1 in bracket a plus 1. Then I put this second one behind. So that is my final answer for that. This is another one. In this case, when you look at this question, it doesn't look directly like difference of two square. But if you look at 36, 36 is 6 square. So this will be 6 square x square, which is equal to 6x in bracket square minus 1. Then this one will give me 6x minus 1 in bracket 6x plus 1. This is another one. When you look at this one look a little bit complicated. 3 minus 8c7y square. But I see something here that 3 can go in 3 and 3 can go in 8c7. So let me first of all take 3 out and let us see what happens. So this is 3 bracket 1 minus 289y square. Now 1 minus 289y square is the difference of 2 square. Why? Because 17 square is equal to 289. So I can see that this one give me 3 bracket 1 minus 17 square y square, which is equal to 3 bracket 1 minus 17y all square. So 1 minus 17y all square will give me 3 bracket 1 plus 17y bracket 1 minus 17y. So 3 bracket 1 minus 17y bracket 1 plus 17y. This is the final answer for that. Now this is another one. In this question, I have 3x squared minus 64y squared. One can just think of, since 36 is a perfect square and 64 is a perfect square, can just think that 6 square x squared minus 8 square y squared. Then the final answer will be 6x minus 8y in bracket 6x plus 8y in bracket. This one will not completely factorize the question. So when you look at this question carefully, you discover that 4 can go in 36 and 4 can go in 64. When 4 go in 36 is 9. When 4 go in 64 is 16. And when you look at this, 9 is a perfect square and 16 is a perfect square as well. So I can change 9 to 3 square and 16 to 4 square. So which is equal to this 3x all square 4y square. So my final answer will be 4 bracket 3x minus 4y bracket 3x plus 4y. So this is how far we go under this topic. I want you to try to master everything we've done here. Then try to lay your hand on as many questions as possible. And I'm very sure that you'll be glad you do.